Hello and welcome to the tutorial video on the first time setup of the Tycho software. If you are new to Tycho, there is a website here. This is tychotracker.com, and that's tycho-tracker.com. And what you want to do if you are getting set up with this software for the first time is to navigate to the download page. So when you go to the download page, you'll see different sets of items that can be downloaded. So you could download programs, you could download data sets, or you could download catalogs. So for this purpose here, the first thing we want to do is to download the Tycho software. And you could download either the setup installer or the version without an installer. So typically I like to use the setup installer. That way it installs into the program files directory and it installs into your start menu and so forth. But again, that's up to you. So choose one of these, and then after you've done that, you can go ahead and launch the Tycho program. So whenever you launch it for the first time, you should see a set of windows that should look similar to this. So you have the image manager. This is where you would load images into the program. You have a status window here, and this will indicate whenever it's processing data. It will sometimes give a progress bar. Whenever it's downloading observations from the MPC website, it might indicate that, and so forth. Right now you can see that it currently indicates that we have GPU acceleration disabled. So that is the default setting, is that it knows nothing about your GPU hardware other than that again, by default, it's just going to use CPU only mode. So it will not use a dedicated card until you have configured it for the first time. So if you want to do that, you can navigate to the OpenCL menu from the top menu here and choose Device Selector. This will open up a new window entitled OpenCL Device Selection. So if you want to use GPU acceleration, you would check this box, Enable GPU Acceleration, and this will enable a drop-down menu. Now, it's important to note that sometimes this can fool you into thinking that you have a dedicated GPU when in reality you do not. So for example, if you have something to choose here that says it's something along the lines of Intel HD graphics or Intel UHD, that would be considered an integrated GPU. In other words, it's integrated into the CPU, and that's really not useful. In fact, that's most of the time that will not give you the results that you want. So just keep that in mind. Now, if it does say something like NVIDIA Corporation, NVIDIA, then it's most likely going to be dedicated GPU in that circumstance. AMD, there's also a good chance it will be dedicated GPU as well. But again, Intel HD, then that's probably an integrated graphics unit. So once you've decided what to use here, if you want to use GPU acceleration, then you can click OK. But for my example, for my purposes for this tutorial, I'm actually going to leave this unchecked. And that's just to show that Tycho works just fine whether or not you have a dedicated GPU card. So if I want to, I can choose however many threads to use in CPU mode. So again, if you have this enabled, you don't need to worry about that. But if you are in CPU mode, then you can improve the performance by specifying however many threads to use for the stacking operations. So I have a 4-core CPU. It has hyper-threading, so you can multiply that by 2 and get 8 threads. So this allows you some flexibility in that performance. Now, I will say GPU acceleration is definitely worthwhile if you are going to use synthetic tracking or some number of stacking operations of images. You will get up to generally around 40 times performance improvements. So it's very much noticeable if you do have GPU acceleration. So anyway, keep those items in mind. And so for now, I'm going to click OK. So the next item on the list for the first time setup is to configure the known object module. So this is basically where you can match candidate detections with known objects, or you might simply want to know what are the known objects in a given field of view. So this is a module that you can set up for that task. So what you first want to do, again, first time setup, is go ahead and download the MPC Orb database file. This is the Minor Planet Center Orbital Element Database. So this basically has all of the asteroids and near-Earth objects in it, but it does not have the comets. So if you want comets, then you download the comet file. So I click that button, and that's a very fast download. And the last thing I like to do is verify the total database. It will go through and verify both of those files. So I click that button, Verify Database, and it comes back and says that we have 1.1 million objects in the MPC Orb file, and about 3,700 in the Comet file, and I'm not using any custom orbital elements, so there are 0 items there. Now, if I wanted to, I could specify a MPC orb.custom file that would contain custom orbital elements, but that's for another topic. So for now, the other settings here, the initial search margin 1.5 degrees, that's a reasonable default. If you are going to work with comets on a regular basis, then I would go ahead and check this box. It will slow the search down a little bit because it has to search a wider area, but it will basically, it will improve the matching when you're working with comets. So I'm going to go ahead and check that box. That's up to you. And the other thing I want to do here is number of parallel find orb instances. I'm going to choose 6 parallel instances. Again, I have 8 threads available on my machine, so this leaves it where it's not going to overwhelm my system with too much processing all at once. So again, you have that flexibility. The next item here, the track identification parameters. These are essentially the match thresholds. So you have distance, speed, and position angle. Distance being how close the objects must be to be considered a match. Speed is how similar their speeds must be, and then finally position angle. So how similar the direction in movement, how similar that has to be. So if all 3 of these are satisfied, then it is considered a match. So generally, this is an acceptable default. You may still occasionally get a false match, and that's perfectly fine. What will happen is typically you'll see it in the track navigator window. The distance column will basically be higher than normal. So generally, a match with distance of 0.2 arc minutes or less, that's a very good match. And if you start to see one above that, if it's 0.5, 0.6, then that starts to call into question whether or not it is actually a valid match. So as you get more practice, you'll start to figure that out. These would be reasonable default settings to use. So you can click OK. So we have now configured known objects. I would now suggest to configure the star catalog. So again, if you're doing any kind of astrometry or photometry work at all, you need to have a star catalog. So if you want to, if you're just starting out and you want something really basic, then you could use the UCAC4 catalog, and this is something that you could have available as through an online service. You would not even have to download a local copy of it. So you could check this box to access through an online service and choose the desired server and so forth. But in my example, I would like to use a local, an offline catalog, and this is also available on the Tycho website. So if you go to the download page, then you'll see the section for catalogs, and if you want to, you could choose up to Mag 20 on Atlas. So Atlas is a great catalog, and in fact it's very good not just for astrometry, but also especially useful for high precision photometry. And so, in fact, it's actually recommended by the Minor Planet Bulletin, the authors of the Minor Planet Bulletin. So if you are interested in doing photometry work, Atlas is the catalog for you. So again, with that, I would choose, again, up to Mag 20, just depending on the kind of work you're doing. Other software, they limit it to Mag 16, but here, if you want to, you can use up to magnitude 20, and that is in fact, that is the cutoff point of the actual original distribution of the catalog. So it really only goes up to magnitude 20. And that is a larger download. It is 13 gigabytes, so keep that in mind. That might be one reason to choose the magnitude 16 option instead. So once you have downloaded it, then you will need to specify the path where you have extracted that archive. You should see a directory structure that looks similar to this. So whenever you point to the path in Tycho, so again, for me, I say catalog atlas, and then I've extracted it to catalog atlas magnitude 20. You should see this kind of directory structure where you have 180 folders. So you've got basically declination 0 to 90 for north and 0 to 90 for south declination. So you have 180 folders, and again, that will correspond to essentially the root directory of your catalog here. So that is where that is how you point to it in Tycho. So with that, then again, if I want to use Atlas, then I would choose it from the drop-down here. And also for Atlas, the native magnitude band is the Sloan R. And this is where, again, another recommendation from the Minor Planet Bulletin, where they say when you're conducting photometry, it is recommended to use the native magnitudes of the chosen catalog. So in the case of Atlas, that is the Sloan R magnitude. So that is where we'll choose Sloan R as the magnitude band. And in my case, I am not using a filter, so you can choose clear none if that applies to you as well. And I also like it to load the catalog automatically, so you can check this box if you want to. And these other default settings are pretty much valid for this tutorial. So I'm going to click OK. Okay, so the next item to configure is the tracker. So go to Settings, Tracker, and the default setting here for the number of tracks is perfectly reasonable. So I'm just going to leave that as 1,000. Again, you can adjust it if you want to, but the next item is the track confidence routine. So whenever it comes back with a list of candidate detections, you have the option of running a confidence routine to help determine which of these candidates are likely to be real, which ones are likely to be false. So basically the default here is normally what you want, but I did put out a tutorial video on how to create your own custom confidence model if you wish to do that. But for this tutorial, just go ahead and use the default setting. And you also have the option of automatically loading known objects, automatically computing confidence. For now, I'm just going to leave these as the default, but you can check these if you want to. So click OK. The next item, let's go ahead and skip to the Find Orb software. So Find Orb is very useful for computing the orbits of objects based on a set of measurements. So it's highly recommended that you install and configure this. And so this is also available, the modified version of it is available from the Tycho website. So if you go to the program section, you have the Find Orb software. So this has been modified to work with Tycho. And here is the version that's released July 20, 2021. So you go ahead and download that, and then you would specify the path to these 3 different executables. So the first 2 are Windows front ends to Find Orb, and then the other is a sort of a command line variant of it. So you go ahead and specify the path to these executables. And then once you have done that, the other thing to note is that you really want to make sure you are not placing it into the C root directory. And by that I mean don't just extract it into C:/ the root directory. In other words, if you do that, then you will have to run with elevated privileges because that's just the way Windows is set up, is that if you have a program in C root directory, then you have to run it as essentially an administrator. So what will happen is if you were to do that, then it won't be able to write basically files and settings and object data to its folder. You'll just run into all sorts of issues. The safe way to go about this is to extract it to the desktop or the documents or some other folder where you have write permissions. So in my case, I just went ahead and left it in the download folder. So that's what you can see here, and that works perfectly fine. So once you've configured that, you can click OK. And the next thing I want to do is set up the observatory codes. So this is obs codes, and this presents a window here. And what we care about is going ahead and populating this file. This is download obscodes.html. So if you click this button, then it downloads that file. And then because we have configured the find_org program, we can also click this button to copy that to the find_org directory. So it will say copy OK, and if you want to, you can also verify. So you click that button and it says that there are over 2,200 observatories that have been identified. So that this gives you confidence that indeed you have downloaded the correct file. So now you can click OK, and we've made a lot of progress so far. The next item that we'll want to configure is the observatory. So you might have multiple observatories that you're working with, but for this tutorial I'm just going to add one. So this is the Sighting Spring Observatory that captured the DS1, 2, and 3 data sets. So these are data sets that are also available on the Tycho website. So you can go ahead and give it a label, Sighting Spring in this example. And this one already has a Minor Planet Center code, so you can choose this option. The other two options are, if you are applying for a new code, then you might use this option, or if you are a roving observer, maybe you're doing some sort of mobile observatory, portable observatory, where you go out to different locations, then you might choose this option here. But for this example, that we already have a Minor Planet Center code for this observatory, and in fact its code is Q62. And because we have downloaded that obscode HTML file, it knows the location of that observatory based on that code. So if you click this button, then it will automatically populate these fields. Otherwise, if it is an unknown observatory, then you may have to enter these values yourself, the latitude, longitude, height, and so forth. And I'm just going to use the default telescope design here. There are actually several telescopes at this location, but if you are configuring your own observatory, you probably want to go ahead and make sure to type in the correct parameters here. Then go ahead and click Next. Okay, so here you have the camera details. So this telescope and this observatory, you would have a given camera associated with it. Now the truth is, you might actually have several telescopes at your observatory, each having their own cameras, or you might have one telescope with multiple cameras. The way to handle that is to simply add multiple observatories, and they would then be defined as having different telescope and camera parameters. So even though they are all at the same physical location, you can simply add multiple observatories with different labels to indicate which one has what kind of camera or telescope. So again, for this tutorial, I am going to use the camera settings, the camera's details associated with this Sighting Spring Observatory. So the cameras here, they have date obs, refers to beginning of exposure, but there are some cameras, some of them will have it where it refers to end of exposure. And this is important because if you get this wrong, then you generate a measurement and the timing info is incorrect. And of course, if you are measuring a near-Earth object that's going by very quickly, then that timing info is quite important. So that's what I'm going to do here is, again, the camera for this example, it does refer to beginning of exposure. So I'm going to use this option. Time offset, ideally you should not have to have a time offset. So this is basically used as a band-aid, a fix for some other issue. So if you have a camera where the timing source is incorrect by some consistent amount, then you could use this option here to offset it by some correction amount. But again, it would be preferable to correct that error up front, that issue up front. But this is an option if you need it. The precision can be both with timestamp and position. So normally you will want to use the normal setting, the default setting. However, there may be a scenario in which you want to use a more precise extra precision. But do keep in mind that the MPC does not allow all observatories to use extra precision. In fact, they might even reject your measurements if you try to submit with extra precision. And that's typically the case with the position field. You can normally get away with it on the timestamp field. But for here, this tutorial, I am going to use the default normal precision. Now, the last item here, CCD characteristics. So this would be used whenever Tycho wants to compute the signal-to-noise ratio of an object. The proper way to do that is to take into account these camera parameters. So the gain, the readout noise, the dark current. So if you really want to make sure that you have computed the SNR of an object correctly, then you might want to go ahead and look up these values for your camera. But for my purposes here, for this tutorial, I'm just going to use the defaults and then click Finished. Now, if you do have multiple observatories added in the list, then you'll need to select the desired observatory to use and then right-click and choose Make Active, or you could choose Make Active from this menu here. Either way, it will not automatically make a new observatory active. You have to do that explicitly. Okay, the next item to configure is the section on report parameters. So go to Settings, Report Parameters, and you'll notice that the first item here are the persons involved. So what you would do is type in the first initial followed by a last name. And so if you are sharing credit with another observer, then you could put them either in the measurer field or in the observer field, potentially also in the submitter field as well. So you can specify up to 3 different individuals involved in the observation. So again, this is first initial followed by last name. So you have this flexibility to specify these different persons involved. The contact email, so if you are submitting light curve data, then you can specify a contact email address. There's also a field to specify email addresses for the AC2 line. This is sort of an acknowledgement that you might receive from the Minor Planet Center whenever you submit your measurements. This is optional, so you can leave it blank if you want to. And then finally, the magnitude information. So there are a couple of scenarios where you may want to omit magnitude information. So one would be if the object is too faint, if the SNR is such that even with stacked images, it is at or very near that of the background, then you will not be able to generate a meaningful magnitude. So this is the flux. If that measured flux is less than a certain value, then you might want to omit it. The other scenario is whenever the object is too close to a star, then you would have it contaminated with the flux from that star. So certainly if it is in front of a star, then the computed magnitude would be invalid. So these are both different options available to you. If you find that it is omitting the magnitude more often than you would like, then you can either adjust these parameters or simply uncheck them altogether. So once you have configured that, you can click OK. Okay, so for the last part of this video, the last remaining items that I would consider as part of first-time setup, these would be under the Action menu. So this is calibration, alignment, and plate solving, and maybe possibly resizing. These are basically settings that you configure for the most part once, and then you leave them unchanged. So calibration, you have a pop-up window here, and you can specify a dark frame, a flat frame, and some other options. So if you wanted to have a dark frame, you would specify its path, or possibly specify a directory from which it would automatically select a dark frame based upon its exposure time and the exposure times of your images. But for now, I'm going to skip that. And flat frame, again, you could either specify a flat, or in this case, you could use a pseudo flat. So pseudo flat is very nice because not only does it flatten each image, it also computes a new background level such that the images are normalized, where they have consistent background level from one image to the next. And that's very useful. It's very important actually for the synthetic tracker to work optimally, is to have that consistent background level. So you can use pseudo flat, and if you do so, then you will not need to perform this option. So you could have it where you use pseudo flat, and you could leave this unchecked. But if you are going to use a normal flat frame, then you should go ahead and check normalized images, again, if you are using the synthetic tracker. Now, if you have primarily an interest in photometry or constructing light curves, then you actually, in that case, probably do not want to normalize the images, because in that circumstance, you would want to leave the signal unchanged as much as possible. So for photometry work, I would leave this unchecked. So either way, go ahead and determine what the appropriate settings are for your system and for your setup, and then go ahead and choose Save Settings. And then you have calibration is done, and again, you can always change it later, but this is first time setup. The next item that we would care about would be align images. So here you can specify what kind of alignment routine you want to invoke. You can use an external program such as Registar or PixInsight, or you could use the internal alignment routine of Tycho. So by default, the default setting is internal, and each of these has their own set of options. So internal, you can specify however many threads to use. That can speed it up quite a bit. So I might choose 8 threads, and that will make it really fast. Interpolation is either bilinear or bicubic, so we'll just use the default there. And the mode of operation, you can choose fastest or normal. So if you want it to be robust alignment that handles a wide variety of scenarios, maybe you have a meridian flip or something like that, then you should choose normal. But if the images are already closely aligned, then you can get away with using the fastest mode. The final option here would be to use distortion correction. Now that will require essentially normal mode, but basically this would be your slowest alignment, and it would be useful if you've taken images from a wide field refractor, for example. So this is distortion correction, and it is an option as well. So just keep these options in mind. If you see results that don't look like they ought to, then just go back here and make sure that these settings match up to the images that you have loaded. So once you have specified the desired settings, then you can click Save Settings to proceed. Finally, the last item to talk about in this video is the plate solver. So again, this is under the action menu. So go to plate solve images. So even if we don't have any images, we can go ahead and configure this component here. So there are two different solvers. One is an online solver, the other is an offline solver. And most everyone will want to use the online solver. It's easy to use, and it really does a great job of solving nearly every single image out there. So I would recommend using it. And so that is the default setting. The next important item to make note of is the solver settings. So regardless of which one you use, online or offline, these settings will apply to both. So this is where you would specify a lower and an upper bound on plate scale. So the default here has a fairly wide range, but if you have images that are highly sampled, you might have to reduce this lower bound even more. And so conversely, if you have perhaps a very, very undersampled image, then you might have to increase the upper bound. Either way, the default should work for most everyone, but again, there's a way to customize that. Downsample factor, again, it says here 2 is usually best, and that is true. However, if you have very few stars in your image, or you've got simply a very narrow field of view, then you might want to choose a downsample of 1. On the other hand, if you have a very wide field with lots of stars, then you might want to choose downsample of 4. So keep that in mind. If you have issues getting a plate solution, then you really do want to make sure that you experiment with different downsample factors. So if you know for sure that your plate scale is configured appropriately here, then again, this would be the next item to check. So additional options here, if you want more output from the solver as it processes the image, then you can check this option. You could also try this one here to try a different image in a set, but again, the default settings here are typically useful. And the last item would be, if you know that your image has a correct, basically a correct initial plate solve, if you will. It's really not a plate solve, but it's an initial position information in the FITS header, the header of the FITS image. Then you can choose this option to narrow the search so that it does not have to search or do a blind search of the whole sky. So most of the time this is acceptable, but again, if you are having issues with it not returning a plate solution, then you may either want to increase the search radius or simply uncheck this option. So that is an option there. Again, additional flexibility. So once you have configured the solver, then click Save Settings, and now you have completed the first time setup.